Hi all, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Topic: Definitions and terminology of electron beam or laser beam machining. Okay, right. Already we have discussed the content beyond the syllabus of unconventional machining process that we have discussed. Rapid prototyping. Okay, so various methods like stereolithography and fused deposition modeling and all these things. Okay, so however, again we'll have to make one bridge between these content beyond the syllabus and the present unconventional machining definitions and terminology. Okay, right, right. What is laser? Laser is an acronym of light amplification by stimulated emission of radiation. Okay, LASER. Light amplification by stimulated emission of radiation. Stimulated emission of radiation. In short, it is laser. Okay, it is an acronym. Okay, right. It is an electromagnetic radiation. It is an electromagnetic radiation. It produces a powerful monochromatic collimated beam of light in which the waves are coherent. Okay, so this is laser. Okay, laser is an acronym of light amplification by stimulated emission of radiation. Okay, light amplification by stimulated emission of radiation, that is laser, LASER. Okay, right. State the principles of laser beam machining. LBM means laser beam machining. LBM. Okay. In laser beam machining process, laser beam is focused on the workpiece by means of lens to give extremely high energy density to melt and vaporize the work material. Okay, so here this is workpiece. So here the laser beam focused on the work by means of lens to give extremely high energy density to melt and vaporize the work material. Okay, right. What are the characteristics of laser used in laser machining? Okay, what are the characteristics of laser used in laser beam machining? Right, it can be focused to maximum intensity or to minimum intensity as needed. Okay, so here the laser beam must be having minimum to maximum intensity levels. Okay, so it can be focused to maximum intensity or to minimum intensity as needed. Okay, so based on the application, we have to maintain the variations of intensity by the laser beam. Okay, right. It can be moved rapidly on the workpiece. Okay, it can be moved rapidly on the workpiece. Next, third one. It is projected on the workpiece at particular distance from the lens. Okay, so we need not worry about the workpiece distance. Okay, so we can project the laser from a distance through lens. Okay, next. Dedicated to an online process. Dedicated to an online process. Okay, power is shared on a job. Okay, so these are the different characteristics of laser used in laser machining. Right. Give the examples of solid state laser and gas laser. Okay. Solid state laser and gas laser. Okay. Under solid state laser, the following are the things: ruby laser, okay, neodymium dropped yttrium, okay, next aluminum, next garnet, that is YAG laser, okay, next neodymium doped gas laser, okay, next under gas laser, CO2 laser, carbon dioxide laser, okay, helium neon laser, okay, these are neutral gases, okay. Helium neon laser, okay, right. What are the basic requirements of laser welding? Okay, so the following are the basic requirements of laser welding. The focus of the beam should be adjusted to the thickness of the material. Okay, the focus of the beam should be adjusted to the thickness of the material. Okay, second one, the wavelength of the laser beam must be compatible with the material being welded. Okay, the wavelength of the laser beam must be compatible with the material being welded. Okay, what is solid state laser? Okay, what is solid state laser? Solid state laser is the lasers which consists of a hot at which may be crystalline, solid or glass, doped with an active material whose atoms provide the lasing action. Okay, solid state laser is the lasers which consist of a hot net which may be crystalline, solid or glass, doped with an active material whose atoms provide the lasing action. Okay, right. How does laser melting works? How does laser melting works? It melts and vaporizes the unwanted material by means of narrow pulsed laser operating at 2 to 100 pulses per second. Because of this high accuracy is not possible to microsize holes. Okay, how does laser melting works? It melts, okay, two things, one is melting and the second one is vaporizing. It melts and vaporizes the unwanted material by means of narrow pulsed laser operating at 2 to 100 pulses per second. Okay, so because of this high accuracy is not possible to microsize holes. Okay, right. What are the characteristics of laser beam? Okay, so the following are the characteristics of laser beam. First one, material removal, material shaping, welding, thermokinetic change. Okay, so these are the characteristics of laser beam. Okay, material removal, material shaping, welding, thermokinetic change. Okay, right. What are the fundamentals of photons used in laser? What are the fundamentals of photons used in laser? In the laser, the photons are in ground state at 0 degrees centigrade. They are brought to the excited state by means of absorption of energy by temperature change collision. Okay, so here one is temperature change and the other one is collision of the atoms. Okay, so in the laser, The photons are ground state at 0 degrees centigrade. They are brought to the excited state by means of absorption of energy by temperature change and collision. Okay, right. What are the advantages of laser drilling? No physical contact between work group pair. Hence, there is no possibility if break or wear of root. Okay, no physical contact between work group pair, and hence there is no possibility if breakage or wear of root. Precision location is ensured by focusing the beam. Large aspect ratio can be achieved. Okay, no physical contact between work group pair, hence there is no possibility of breakage or wear of root. And next, precision location is ensured by focusing the beam, and large aspect ratio can be achieved. Okay, so these are the advantages of laser drilling. Okay, right. List the applications of laser beam machine. Okay, it is used for making small holes, difficult in welding of non-conductive and refractory materials, cutting complex profiles in thin and hard materials. Okay, and second one, it can be used for mass micro machining production. It can be used for mass micro machining production. And third one, it can also be used for selective heat treating of materials. It can also be used for selective heat treating of materials. Right? Let me reiterate the applications. For making small holes, difficult welding of non-conductive and refractory materials, cutting complex profiles in thin and hard materials. It can be used for mass micro machining production. It can also be used for selective heat treating of materials. Okay, so these are the applications of laser beam machining. Right. List the advantages and limitations of laser beam machining. Okay, list the advantages and limitations of laser beam machining. Right. Advantages: machining of any materials, including non-metal, is possible. Okay, can machine any material, including non-metal. Okay, is possible. That is one of the greatest advantages of this laser beam machine. Okay, with other machining process like electron discharge machining and all these, okay, cannot machine. Why? Because they must have some other parameters. But here, laser beam machining, we can machining any material, okay, including non-metal. Okay, so it need not be electrically conductive. Okay, right. Next, micro-sized holes can be machined. Okay, micro-sized holes can be machined. Next, heat affected zone is small around the machine surface. Okay, so obviously that laser beam is a surgical type of machining process. Exactly, it remove the material at particular point, so there will not be any heat affected zone. Okay, right. Now let us come to limitations. Highly skilled operators are needed. Okay, dealing laser is very dangerous, and at the same time, if we won't use properly with high skilled operators, then it will be a problem. Why? Because it has to follow the exact path. We have to check the CAD model profile before and after the completion of the machining process. Okay, so exactly the laser beam should deflect through the lenses or mirror. Okay, as on to the specified path given by the input of CAD model. Okay, so that it should be checked frequently by the high skilled operators. Right. Rate of production is low. Okay, that is one of the limitations or disadvantages. Obviously, initial investment is high as the laser setup is costly. Okay. Next, life of flash lamp is short. So obviously we need to replace the flash lamp frequently because its life is very small or short. Okay. So right, with this we have a good knowledge on advantages and limitations. But the thing is that uh, based on the requirements of the clients, we have to go with the laser beam machining or electro discharge machining, etc. Okay, right. What are mechanical actuators? Okay, what are mechanical actuators? Using pulleys, gears, rails, and chains, a mechanical actuator converts the rotating motion of physical objects into linear motion. Okay, so one common example is rack and pinion steering systems. Okay, so this is the mechanical actuator type. Okay, what materials can be machined by using laser beam? Okay, so by using laser beam, we can machine the following types: all materials except those high thermal conductivity and high reflectivity. Okay, so here high thermal conductivity and high reflectivity materials cannot be machined. Okay, so sometimes in some machining process, the material should having high thermal conductivity, but here if it is having high thermal conductivity, we cannot machine by using the laser beam setup. Okay, right. What are the characteristics of laser used in laser machining? Okay, what are the characteristics of laser used in laser machining? Right, can be focused to maximum intensity or to lower intensity as needed. Okay, so here from minimum to maximum intensity levels of laser beam is needed in order to serve for the different applications. Okay, next second one, can be moved rapidly on the work. Can be moved rapidly on the work. Third one, remote cutting over long standoff distances. Okay, so we can operate the laser beam machining from a long distances because the laser beam itself is dangerous for the human, so that we can operate with online setup and which can be maintained with the some distance. Okay, right. State the working principles of EBM. Working principles of: when the high velocity beam of electrons strike the workpiece, its kinetic energy is converted into heat. Okay, this concentrated heat raises the temperature of work material and vaporizes a small amount of it. Okay, resulting in removal of metal from the workpiece. Okay, the high velocity beam of electrons strike the workpiece, its kinetic energy is converted into heat. This concentrated heat raises the temperature of work material and vaporizes a small amount of it, resulting in removal of metal from the workpiece. Okay, so here kinetic energy is converted into heat, and that heat raises the temperature for the workpiece material so that it melts and vaporizes. So by this way, the material removal will be taking place. Right. List any 4 limitations of electron beam machining. The metal removal rate is very slow. It is not suitable for large workpieces. Cost of equipment is very high. A little taper produced down holes. It is applicable only for thin materials. Okay, so it cannot be used for thick and large sized parts or products. What is the drawback of electron beam machining? Okay. One major drawback is the diameter of electron beam welding has been the requirement of high degree of vacuum essential or satisfactory operation of this process because of degassing. Okay, right. Write the application of electron beam. Okay, so we can deploy for thin filming machining, surface treatment, engraving metal and non-metals, cutting of materials. Okay. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.